Hey everyone, welcome back to our channel. Today we're blasting off on a deep dive into the Falcon 9 rocket and its launch failures. This incredible machine has become a cornerstone of modern space exploration, and for good reason. Let's break it down. But first, what is the Falcon 9 rocket? The Falcon 9, developed by SpaceX, is a partially reusable launch vehicle that's become a cornerstone of modern space exploration. The Falcon 9 project began in 2005 with the ambitious goal of creating a reliable and cost-effective way to get payloads into space. The maiden flight of the Falcon 9 took place in June 2010, marking a significant milestone for SpaceX. Since then, it's become a workhorse for a wide range of missions, from launching commercial satellites to carrying astronauts to the International Space Station. With a total of 321 launches, 279 landings, and 252 reflights, the Falcon 9 has been breaking records for a while now. Here's a breakdown of its key features and accomplishments. The Falcon 9 is a formidable presence on the launch pad, towering at 70 meters, which is approximately 230 feet tall, with a diameter of 3.7 meters, which is 12 feet, roughly the size of a school bus. The first stage of the Falcon 9 is powered by 9 Merlin engines, burning a mix of liquid oxygen and rocket-grade kerosene. These engines generate more than 1.7 million pounds of thrust at sea level, providing the immense initial push needed to overcome Earth's gravity. In terms of its payload capacity, the Falcon 9 boasts an impressive payload capacity of 22,800 kilograms, which is 50,300 pounds to low Earth orbit. This allows it to carry a diverse range of payloads, including commercial satellites for internet access, communication, and Earth observation, cargo resupply missions for the ISS, the Crew Dragon capsule, carrying astronauts to and from the ISS. Let's talk a bit about its reusability. One of the most revolutionary aspects of the Falcon 9 is its reusability. Unlike traditional rockets where the first stage is discarded, the Falcon 9 booster is designed for a controlled descent and landing. It performs a series of maneuvers and engine burns to slow down and guide itself back to Earth. It fires its engines in a calculated way, slowing itself down and guiding itself back to Earth. Imagine a controlled fall from space. That's what the booster does. Now, there are 2 landing options. Sometimes the booster aims for a designated landing zone on land. Other times, it targets a giant drone ship stationed in the ocean. Landing on a moving platform in the middle of the ocean? Talk about a bullseye! This reusability is a game changer. Traditionally, launches cost hundreds of millions because the entire rocket was expendable. With the Falcon 9, SpaceX can recover and refly the booster multiple times, slashing launch costs down to around $67 million per launch. That's a massive difference, opening doors for more frequent missions and making space exploration more accessible. SpaceX strives for constant improvement. The Falcon 9 isn't just powerful and reusable, it's also a workhorse. In 2022 alone, it completed a record-breaking 60 missions. It's been used to launch a mind-boggling variety of things. Of course, no machine is perfect. The Falcon 9 has experienced a few launch failures in the past. Let's go over 2 of them. First, we have the SpaceX CRS-7. It was supposed to be a routine delivery. On June 28, 2015, a SpaceX Falcon 9 rocket stood poised on the launch pad, its belly filled with over 5,500 pounds of cargo destined for the hungry crew of the International Space Station. This was CRS-7, SpaceX's 7th mission for NASA's Commercial Resupply Services program. Excitement crackled in the air as the countdown echoed. But then, disaster struck. Just as the rocket ignited, separating from the first stage was supposed to be a smooth ballet. But this time, something went terribly wrong. A tiny, seemingly insignificant strut pin, tasked with holding the first stage together, snapped. It was like a domino falling in a precarious chain reaction. The broken pin triggered a structural failure within the liquid oxygen tank, a crucial component filled with supercooled propellant. The tank breached, unleashing a torrent of the freezing liquid. But liquid oxygen doesn't stay liquid for long in the fiery world of rocket launches. It instantly turned into gas, expanding in volume at an alarming rate. The pressure within the tank became immense, a ticking time bomb. And then, the unthinkable happened. The entire rocket erupted in a fiery explosion, a heartbreaking spectacle that devoured both the Falcon 9 and the precious cargo it carried. The silence that followed was deafening. Thankfully, there was no loss of human life as this was an unmanned mission. But the financial and emotional toll was heavy. This setback sent a shockwave through SpaceX, delaying missions and raising questions about their reliability. Yet amidst the ashes, a crucial lesson emerged. SpaceX didn't shy away from the harsh reality. They launched a meticulous investigation, determined to understand the gremlins in their machine. The culprit? That same seemingly insignificant strut pin, a design flaw that had slipped through the cracks. It was a stark reminder that in the unforgiving world of rocket science, even the smallest detail can have catastrophic consequences. The CRS-7 incident may have been a dark chapter, but it became a turning point for SpaceX. It pushed them to prioritize safety and meticulousness, paving the way for a future filled with more successful launches and a deeper understanding of the challenges of space exploration. Secondly, we have Amos 6. The year was 2016. Anticipation hung heavy in the air as SpaceX prepared to launch the Amos 6, a powerful Israeli communications satellite, into orbit. This mission marked a significant step forward, carrying not just cargo, but a vital piece of technology for global communication. The launch pad buzzed with activity, the countdown a rhythmic pulse leading to a spectacular liftoff. But fate had other plans. Disaster struck not during the fiery ascent, but in a seemingly routine pre-launch check. During a static fire test designed to mimic the stresses of launch without actually leaving the ground, a seemingly innocuous component, a helium bottle within the second stage, unexpectedly ruptured. This seemingly small event triggered a catastrophic chain reaction. Imagine a tightly wound spring suddenly snapping. The ruptured helium bottle unleashed a torrent of the inert gas, but it wasn't just the pressure that caused the problem. The high-pressure helium acted like a bullet, puncturing the surrounding fuel and oxidizer tanks. In an instant, the precisely calibrated balance of the rocket was thrown into chaos. The flammable propellants, now exposed to each other, ignited in a blinding explosion. The Amos 6 satellite, nestled atop the Falcon 9, was no match for the inferno. Both rocket and payload were reduced to a fiery debris field. The aftermath was a scene of devastation. The launch pad, once a testament to human ambition, lay scarred. The Amos 6 satellite, a marvel of engineering, was nothing more than twisted metal. The financial losses were significant, but the emotional toll was even greater. But SpaceX, under the leadership of Elon Musk, is known for their resilience. They refused to let this setback define them. Instead, they launched a relentless investigation. SpaceX learns from these setbacks. They analyze every detail, identify the cause of the failure, and implement changes to prevent it from happening again. So there you have it, the mighty Falcon 9. A powerful, reusable, and reliable workhorse that's helping us reach new heights. Thanks for joining me on this Launchpad learning session. Let us know what you think about the Falcon 9 in the comments below. Like and subscribe, and we will see you in the next one.